Hello everyone, welcome back to our channel. Today we have an interesting topic. We are going to extract some important damage data and load displacement data available on peer structural performance database for a variety of specimens. We will also automatically save the extracted data into an Excel file. This data extraction is very fundamental to performing machine learning studies. In recent times, there are many publications that has been published on failure mode classification. In those studies, the experimental data of RC columns reported in peer structural performance database served a very critical role in building up the machine learning model. This is how our peer structural performance database looks like. To download any RC column experimental data, we just have to click this search button and we have to choose the parameters to shortlist the specimens that are available on this peer database. I'm just shortlisting this rectangular columns and I'm selecting this concrete crushing as parameter and clicking this search button. So after that we get these much list of RC columns. So if you open any of this link, so you will be seeing a data like this. Here the concrete crushing, concrete spalling and other damage data will be presented, and here you will get this experimental load displacement data. So on the first column you have this displacement, on the second column you have this load. Generally when you are dealing with a limited number of specimens like 3 or 4, we can always manually extract the data. But when you are dealing with more number of specimens like 100 or 200, manual process is very tedious. In this particular search we have got 85 number of matching records, and manually extracting this damage data and load displacement data or any other geometric data from this particular web page of all these specimens is very difficult. So if you have any algorithm or any particular code that can automatically download this data, then that code will save you a lot of time and money. After extracting this data from this website, you can perform many machine learning studies on the data. After you run our Python code, which we will discuss shortly, you will see the data that saved in this format in an Excel sheet. So you will get the damage data like this, and in sheet 2 you will get the load displacement data. Before we dive deep into today's tutorial, I want to take a moment to thank all our subscribers. Your support really motivates us to consistently provide valuable content in a timely manner. But at present, 80% of our viewers have not subscribed yet. If you like our content but have not subscribed yet, I request you to please subscribe to our channel. It's a small action that goes a long way in encouraging us to create more tutorials like this. Let's dive into today's tutorial. This is the Python code that we have written for this automated data extraction process. These are some of the important libraries we need for this data extraction and further processing of this data. Here, as we know, this matplotlib, numpy and pandas are general Python libraries which we use for plotting and matrix vector operations and file reading purposes. This URL lib is a very important library which we use to process links, and this convex hull and interpolation 1D are the functions of this SciPy module, and we use them in the process of developing backbone curves actually. And here the RE module provides support for regular expressions for text processing. It allows you to search, match and manipulate strings based on specific patterns. When working with web scraping, Beautiful Soap from this BS4 package is commonly used to extract information from HTML and XML documents. Here this URL join of URL lib is used for constructing absolute URLs by combining a base URL with relative URL. This request library is used for making HTTP requests. It is commonly used in web scraping, API calls and other scenarios where communication with web servers is required. And this XML module is used for extracting the information from XML files. And this openpyxl is used to create and store the downloaded data onto Excel files. In this case, the workbook class is used to create a new Excel book that can be populated with data that we just downloaded from the website. This is the main code that we have written to extract the data from the web pages and download that into a specific Excel sheet. In order to get the data from the peer database website, we need a HTML version of this website. So for that, what we need to do is we just have to shortlist the desired number of columns, and we have to download that columns in the form of a HTML file. For example, click this search button and select this rectangle and select some concrete crushing as the parameter. This is the selection criteria I'm using, but you can use any other. It's up to you. Click this search. you will get these many number of specimens. You just have to right click and click this inspect element. So in that inspect element, you will see this body. So here, right click the body and click this edit as HTML. You will see this thing. So all you have to do is press Ctrl A and press Ctrl C. Just I'm copying this entire body and opening a new file and pasting it here. And when I'm saving it, I'm saving it as a HTML file. HTML, just like that. It will be saved as a HTML. I just did the same thing and I have saved in my local as this peer structural performance database.html. So here we are going to use this file. I have generated this file just by copying the HTML version that is available on the website. After saving the web page in the form of a HTML file, we just have to give the file path of that HTML file to this file path variable. After that, here the first function is get data URLs function. This function takes one argument, that is the HTML file. This is our get data URLs function. So if you look at here, what we are doing is this function is returning one list variable called complete URLs. So if you look at this data URLs, this particular complete URLs list contains all the links for this XML references that is given in the web page. So if you look at our downloaded HTML, so this is the XML link that was given in the website. The XML link is this one. So if you take a specimen link on the extreme right, you will have this XML. If you open this XML, you will get the data in this format. So I'm just extracting these links from this HTML web page. If you look at this web link, this link is defined in the format of a relative URL. So basically this link as it is will not work. You have to append an extra term before to this link. And that extra term is this one, NISSC berkeley.edu. I'm appending that term here before this XML link and saving into a variable called a complete URL. So this particular URL get the link of that XML file, and likewise we have so many XML links for many specimens. So I'm gathering all of these things and putting in this complete URLs, another list variable, and I am returning that complete URLs variable from this function. And after getting the complete URLs of each XML file, I'm just passing it to a special function called scrape data. Here for demonstration purpose, I'm just passing one URL. If you want to get all the data that is available in this HTML file, you can just put this line in a for loop such that that for loop will automatically iterate the specimen numbers. So here I am just giving a specimen number 8. So since Python starts from 0 to 7 represents specimen number 8. So let's see what is being done by the scrape data function. This is the scrape data function. If you look at our web page, actual web page, we are going to extract these particular information from this web page. So here crushing is reported at 34.2 mm. Spalling is reported at the same 34.2 mm. Buckling, fracture are reported at 68.4 and 85.5 mm. And there is no fracture and the loss of axial capacity is not reported. So here we are going to extract this damage information plus this particular load displacement data information. So if you look at this text file, so it has two columns. In the first column we have this displacement data. In the second column we have this force data. So we are going to extract this particular load displacement data also and put that in a specific Excel sheet. That's what we are going to do in this scrape data function. And how are we going to extract this particular data means we are going to extract this information from this XML file. So this XML file has all the information that is reported on the web page in the form of XML. So here I have given all the damage types that are possible. We have only 6 damage types on the peer website, that is crushing, spalling, buckling, longbar fracture, spiral fracture and a loss axial. I got these variables from this XML file only. So here if you look at here, crushing, spalling, buckling, longbar fracture, spiral fracture, loss axial, these variables I have got from this particular damage. So these are the keywords I'm using to extract this particular information. And here I'm extracting the values of each particular damage, the number and the unit that is next to that number, mm or anything. So basically it is mm in almost all the specimens, but I'm extracting that as well. And I'm putting that damage data in this results list. So you will get all the damage data of this 6 failure types, irrespective of whether the damage is 0 or not. So, but generally, if you have a 0 value, it means there is no damage observed in that particular damage type. So I'm just eliminating that damage here in this line. So in this result list, finally you will get only a specific time of damage that is observed in that particular specimen. So if there is no damage observed in that specimen, ideally you will get no variable in this results list. After that, I am extracting this particular URL for this text file, and I am storing that particular URL in this data link. These two, the results list and the data link, I am returning from this scrape data function. Once you got this results list and data link, you just have to download the data and put it in the Excel sheet. That's what I am doing here. So if you look at here in this URL, each file name is identified with a specific string like this. So generally you can give any file name for this, but in this particular code, I felt it is easy to identify the specimen if you use the same word that is reported on the URL. So that's why I'm extracting that term from the URL and storing it in this file ID variable. So this file ID variable is used to denote the Excel file name. So this file ID plus this .xlx gives us the resulting Excel file name that we are going to use. And from that we are calling this save to Excel function. This function takes this results list, data link, and Excel file name. So if you see what is written in this save to Excel file here, I'm just converting the results list to a pandas data frame, because pandas data frame is very easy to work with Excel sheets or CSV files actually. So I'm adding a few names for the columns, like in the first column name is damage type, second column name is disp, and the third column name is unit. So I'm just adding and putting all the data with this column names in this results df file, and there I'm saving that particular results df data frame to the first sheet of Excel like this. And then here, using this fetch data from URL function, I am extracting the data, the load displacement data that is available at this web location. So in this fetch data from URL function, I'm just using this URL lib to extract all the data that is available on the URL location on the web page. I am saving the data into a temporary file, and followed that I am doing some text processing. And once we have that data that is read from that web page, I'm converting that to a data frame, and I'm returning that data frame from this fetch data from URL function. So that's it. This particular function will write both this results df and this load displacement data from the web page onto this Excel sheet. So in the first sheet you will get this damage data, in the second sheet you will get this load displacement data like this. In the sheet number 2 you will get this load displacement data. First column you will get this displacement, second column you will get this force. Likewise, after that, just for demonstration purposes, I have plotted the backbone curve of the load displacement data that is downloaded from this particular URL. So this function I have clearly explained in our previous tutorial on decoding hysteresis, plotting backbone curves. I just ran this code. So you see you have got an error. So this error is because we have opened this Excel file. So for now I'm putting it as don't save, means you can save it actually whatever you want. You just have to close this file in order to overwrite that file. If you run this now, it will go well. So it just gives you the data of this damage and this load displacement data. Just for demonstration purposes, I have extracted this damage data and this load displacement data, but likewise you can extract any information that is reported in this XML file You can perform any number of machine learning studies on this data that is downloaded from the peer structural performance database. The specimen data that is reported in this database is very reliable, and the data is validated by many number of researchers in the past. So feel free to download this code and experiment it on your local computers. Downloading instructions are given in the comment section. Check the first pinned comment. Also, we would be very glad if you can share your feedback on this code in the comment section. That's it for this video. See you in the next tutorial. If you have any questions or suggestions, we recommend you to please write them in the comment section below the video. If you like our content, please hit the like button and subscribe to our channel. Happy learning. Thank you.